Hello, this is Susanna Brown, and I will be giving a presentation about the math and reading scores for Miami-Dade School District with data from 2013. Here's the data. We have the raw data over here, which is organized by district number, which also has the school name and the corresponding math score, which has been filtered out for any inconsistencies like blanks or bad data, which are like zeros. So I have created this little chart right here that shows data for the districts 1 through 9 and the math that we have had to compute. What we're going to go over are the median scores, the interquartile ranges. We are going to use a little bit of the box low, mid, high, the air down, up, and the count, as well as the 95% confidence interval right here. So the first thing we're going to look at is the median. Now, as you can visually see, there are some colors on the screen, and what they're representing is green for good scores and red for not so good scores. So the reason why we decided to choose that median instead of a traditional mean, which is just the average, is because the median is less sensitive to outliers. The mean is just taking all of the data in District 1, all of those numbers, but there could be a lot of different things there. So we've decided to stick with the median, which is very helpful when looking at quartiles, which I will show you in a moment. So the median is also quartile 2, which if you're not too familiar with how a bell graph looks, I'm going to show you that next. This quickly is the interquartile range, quartile 1 through quartile 3, and quartile 2 is right down the middle. And this is the area of data that we really want to concentrate looking at, because any of these data points here and over here are not most accurately going to describe the majority of where the students lie, which is right in the middle area. So remember, quartile 2 is median, and that's really what the majority of our scores are going to be represented by. Okay, so now that we know what this stands for, we're going to also see that this and this are the same. And I'm going to show you how we're going to apply those right now. So we have the box and whisker using the air up and down scores. And the point where these two boxes meet right there is the median, or quartile 2. This lower portion is also computed using the box low, the box mid, which is the median or interquartile 2, and the box high scores, and that's what creates this little box. Now if you look at district to district, you're going to see a pattern is emerging, and that pattern is going to carry through the rest of this presentation. And what we're going to see right here is, look at these scores. There's quite a large amount of extremes, which is why I was thinking we should not use the average, which is also the mean. We're using that median score because there's a large variety of data that go from 85 all the way down to what looks like about 5. Down here is the confidence interval with 95% confidence, where the data is going to lie, and where the median score is that little tick mark right in the middle. I've applied these two charts together to transpose into this chart, which is the same as this box from this chart, and the 95% confidence interval right here in the middle. So what we're looking at is the majority of the scores are going to lie right in this area, and where the colors meet, that's the median, or the interquartile range 2, which is the sweet spot for our data. And what's important to know about that is we can see from that last visual on this page, the red boxes for District 1, 2, and 9. Those are our lowest scores, these bright red scores, and kind of a pink score. Those are our low scores. And the same thing if you look at the count, 47, 56, and 60. Those have the highest counts out of all the school districts. Sounds interesting, doesn't it? Well, if we go back here, we can see visually that these are also lower performing boxes as opposed to these schools, which are right in that more desirable range. And if you look at those medians, their medians are much higher than those of 9, 2, and 1. So what's very interesting is when we look at the data that we also can infer some other things. When looking at those same scores for the reading data, we can see that we have also, again, the median scores are lowest in districts 1, 2, and 9, and highest in this bright green and off green color for districts 7, 6, and 8, and a little bit of 3. And these white ones are those sweet spot right in the middle, just the happy average. And if we look again down at the count, once again, those two red scores right here correlate to the highest school counts that there are. And if we look at the same type of visuals that we did right here in the math and apply them to the reading scores, there's quite a similarity. What you can see is obviously the difference between the colors, but you can also see that they form that similar pattern with these lower scores, 1, 2, and 9, performing based on lower medians and the higher school counts. And you can see that's the same as the 95% confidence interval. So, this is the majority of those scores. So now we're going to apply those visuals together. What you can see here is the same data that we have on the previous two visuals charts. So the math right here and the reading, and then we just put them two together. So the arrow up and down right here for math and reading, and then I put them together in this chart to show you those median points. So remember, the median is right here, that interquartile 2 range where those two boxes meet. That is represented right here at the top. So for districts 1, we have a 43 for math, a 39 for the reading median, which is similar to right here, 43 and a 39. And you can see the same things go on through districts 1 and 9. And you can see that same pattern is showing, and that pattern is illustrated right here by connecting those top median points in a line. And from the math point perspective, districts 1 and 2, they actually stayed about the same for different school counts. But look at the difference for this reading. The reading it should, you would think, be about the same like right here, but it dropped. The reading score dropped significantly when the school count was higher. And then once you significantly lower that school count, these numbers appear, these higher percentage of scores, and they both go about the same amount. And so we want to look at the differences of these bigger gaps in between these two lines, like right there and right here for districts 9, 1, and 2, which are also our underperforming schools. We want to see how we can close those gaps. And if you look very closely, you can see, like we were talking about in the previous couple moments, about the sweet spot that is right there in District 5, where those schools are just that happy medium and they're performing not bad, and they're doing pretty good with the account size that they are given. And we've also combined those two charts, which are this one and this one, to make this chart down here, which is showing you the bar graph, as well as the trending line and that gap right around the beginning, and also seen again around the end. The same goes for the confidence intervals. They are about the same pattern as we are seeing in those lines. These ones are lower because those are the reading scores, which is also lower than the math. Now, if we go back up to this chart right here, the median scores, and add in the counts, we're going to see something very interesting. The higher the district school count goes, the lower the scores go. So remember from those medians that the lowest is the 1 district, 2 district, and district 9, with that good amount of data being in 5 as that happy medium spot once again. So when you look at this score right here of a 72 count for schools, for the math, you're going to see about a 43 count for the math right here, which is similar to the district when you increase the school count. Then the scores drop. But what's interesting is the school count only went up a little bit, not nearly as much as the math count, but the math count stayed almost constant, but the reading count is what suffered. And so we need to figure out a way to kind of bring these scores, all of these lines, closer to this x-axis right here, where there's a better chance that the scores for reading and math are going to better align with the count of the schools in the district, as well as right over here. So we probably should reduce the counts from districts 1 and 2 One looks like it has 52, so maybe if we could reduce that by just a few, it would bring that math score up a little bit, as well as 72. If we could reduce that score of schools, reduce the count of schools down to maybe in the 50 to 60 range, which is around the same as some of the higher performing schools, this data point might actually go up higher than the trend line right here. So what we really want to do is improve these areas to help the scores increase. One last way to look at this data is to look, I took the same data as from here to here and I just removed a few things. So all you can see is these lines. This is the school count and the school score. So as you can see, as the school scores or school counts go down, the scores go up. So we want to try to bring those scores to this line, and from District 2, that means we would need to reduce the school count to closer to around 50. We would also need to increase school point 3, maybe closer to 42, which is a little bit closer to this average line. And we're going to do that for probably districts 1, 2, and 3, as well as maybe 8 and 9, because we are going to, as we remove schools from here, we're going to have to put them somewhere. And we're probably going to put them in nearby districts, which geographically we are not sure of with the data we are given, but we will assume that they're probably close in districts 8 and maybe around districts 3. And we can look at the same data as presented here for what we have as the math, and we can actually add in the reading scores as well and look at those in comparison to those blue ones. And so you see that line is very similar. Right here is that good number 5 score right in the middle, and those extra end scores, the 1, 2, and 9, that need attention, and they need to be distributing the classes or the schools in those districts differently in order to try to bring up those scores. I recommend to the superintendent that we really look at the geographical data in addition to the data presented here with the median scores, because it is important to see where we might be able to realistically move certain schools to certain districts, because it might not geographically make sense if a school district in 1 is moved to, say, school district 7, which may be very different socioeconomically and spatially as well. Looking at the data one more time, we have a count of 52 for math when we'd like it to be closer to 45.5, and a count of 72 when we'd like it to be closer to about 52, which is a 20-point gap. And we'll need to disperse that into districts 3, 4, and 5, and we will also need to do the same thing looking at District 9, where we have a score of 75 for the count of schools in that district, and we also have a desired value of 59.5. To get to there, we'll also need to reduce those numbers and distribute to probably districts 8, 7, and 6. The visuals that highlight this point are most the composite visuals with both math and reading and the X and Y axis charts, but the box and whisker plots are very influential as well. Additionally, a bubble plot might be helpful in the future if we were able to combine the geographical location to this data and the bubbles to colors to visually see the difference in the clustered to smaller school districts. But for now, we can estimate these numbers based on this chart right here. Thank you for listening, and I hope this data has helped you make your decision.